I like part 2 of this chapter better because I can check my answers on my calculator, and that just makes it easier for me. Each of the first 4 problems gives me a definite integral, an integral with numbers on it, so I don't need the plus c's. And it asks me to first use my calculator to figure out what this equals to, round to 2 decimals, and then use the fundamental theorem of calculus. So to do part 11a, there isn't going to be any work I'm going to show. It's just all on my calculator. 11a wants me to use my calculator to estimate an area. So on my calculator, I'm going to enter the function 2x. And I don't need to get really fussy with my window. I don't have to set x min equal to 1, x min equal to 5. I think a standard window is going to be adequate. So let me go zoom standard. Any standard window as long as the x's are in between -10 and 10 will work fine to get an answer for question 11, 12, 13, and 14 for that matter. And now I'm going to integrate between 1 and 5 by going second calc, going down to option 7, lower limit 1, upper limit 5. The answer to 11a is going to be 24. I didn't have to round to 2 decimals, so when I go to do 11b, my answer better be 24 as well. So I know the answer to 11b best be 24, and I'm going to get that by hand. So 11b is what I'm going to do for my work. I'm going to integrate this function by adding 1 to the exponent. That x had an exponent of 1, so I'm going to add 1 to it and get an exponent of 2. Divide by the new exponent, and not put a plus c, but put a line next to this that has the numbers that I need to plug in for x. Here the 2's cancel, and I get x squared as the integral, and the numbers I have to plug in are 5 and 1. I'm going to plug in 5 first, and 1 second, and the fundamental theorem of calculus says I have to subtract the results. When I plug 5 in, I get 25. When I plug 1 in, I get 1, and 25 minus 1 is the 24. So it's a super easy problem. 12a, I need to enter this on my calculator and find the area that is indicated here. So I'm going to go to y equals, I'm going to enter parentheses 2x, parentheses, x squared plus 1 squared. That's the function without the dx. I can graph it if I'm interested in seeing what the graph looks like. Ultimately, I just need to go second calc, go down to option 7, lower limit 0, upper limit 1, round to 2 decimals, and I get 2.33. When I go to do 12b, if I know that 0.33 is 1/3, 0.33 repeating, I'd expect to get 2 1/3, and to change that 2 1/3 into a improper fraction, I'd multiply the 3 by 2, get 6, and add 1 and get 7. My hopes is I get 7/3 for an answer when I do part B of number 12. To do part B of number 12, I need to integrate this, and to do this I need to use substitution. I'm going to let u be x squared plus 1, and let me do 2 things in one just to save some space. I'm going to find out the derivative with respect to x, which is going to be 2x. I'm going to change the integral to have u's. This 2x I'm going to change to du dx. I stopped writing the numbers because you actually have to change the numbers when these numbers apply to x's and not u's, and I don't want to change the numbers to be correct, so I'm just not writing any numbers on it. But I changed that 2x to du dx. This x squared plus 1 I'm going to change to u. I'm going to cancel out the dx's and write this as u squared du. I'm going to integrate by adding 1 to the exponent, dividing by the new exponent. So I'm going to get u cubed over 3. Usually I need a plus c, but because I'm going to plug numbers in, the c's would cancel, so I don't need to have numbers there. I need to change the u back to x squared plus 1. And now I'm going to introduce the numbers 0 and 1. Because for definite integrals, you have to plug numbers in. The number on the top of the integral sign we plug in first, and the number on the bottom of the integral sign we plug in second. So into this integral, which is what I got when I integrated and changed the u back to what it needed to be, I'm going to get 1 squared plus 1 cubed over 3 minus the formula for the fundamental theorem of calculus has a minus between the evaluations, and then 0 squared plus 1 cubed over 3. So I just put a 1 in, I put a 0 in, put a minus between them, and now let me figure these out a little bit. The numerator of the first fraction is going to be 1 plus 1 cubed, because 1 squared is 1, so that's going to be 2 cubed. The first fraction is going to come out to be 2 cubed over 3. It's going to come out to be 8 over 3. The second fraction, I get 0 for the numerator, 0 plus 1 cubed, which is going to be 1 cubed. And the numerator of the second fraction, after I simplify it, is just going to be 1. The denominator of both fractions is going to be 3. And now I'm going to do 8 thirds minus 1/3, and 8 thirds minus 1/3 is going to be 7 thirds. So even though I knew the answer ahead of time, I needed to show the work to get that answer. (13) and 14, same sort of problem. For 13, I'm going to do part A. I'm going to enter this function on my calculator. I'm going to integrate between -2 and 0 and figure out the value of that integral. So y equals clear 3 divided by parentheses x minus 5 up arrow, x minus 5 squared. Don't really need to graph it, but I certainly can graph it. Now I'm going to go second calc, go down to option 7, lower limit -2, upper limit 0, and I'm going to round it 2 decimal places. I'm going to say 0.17 for my answer to part A. 13b, my answer is going to be a fraction, and the decimal equivalence of that fraction is actually going to be 0.1714285. I'll write all that down so I can check myself. I don't think I have enough work here to do this integral, so let me do this integral. In fact, I'm just going to do the integral of this function, and I'm not going to worry about the numbers really until the end. I'm going to do u substitution, but before I do u substitution, I'm going to rewrite the problem with a negative exponent. I'm going to let u be the inside of the parentheses, that x minus 5. I'm going to take the derivative with respect to x. That derivative is 1. I'm trying to replace a 3, so I'm going to multiply both sides by 3, and I'm going to get 3 du dx equals to 3. So I'm going to replace that 3 with a 3 du dx. So I get 3 du dx u to the -2 dx. I'm going to cancel the dx's and get 3 u to the -2 du. Now I can integrate. I'm going to add 1 to the exponent and divide by the new exponent. -2 plus 1 is -1. So the new exponent is going to be -1. And I'll divide by that new exponent. I'm going to not need the c's because I'm going to eventually plug numbers in and the c's would cancel out. I'm going to divide that fraction. 3 divided by -1 is -3. So I get -3 u to the -1. I'm going to change the u to the -1 equal to 1 over u to the first. So I can rewrite this as -3 times 1 over u to the first. And this is really -3 over 1 times 1 over u. And that's -3 over u. So almost ready to start stuffing numbers in. I'm going to change that u to an x minus 5 because u is equal to x minus 5. And this whole disgusting interval comes out to negative 3 over x minus 5. Now I'm going to pull these numbers back and go back to my main sheet. I think I went through this kind of quickly because the clock is ticking on my video. It's getting kind of long already and I've only started this. So I'm going to go take all this. It's kind of my side work. This is where I'm going to get the numbers. So I'm going to take the negative 3 over x minus 5, which is what the integral equals to. And I'm going to plug in both 0 and negative 2 and subtract the results. So first I'm going to plug in 0 and get negative 3 over 0 minus 5. And then the minus sign from the formula. And then I'm going to plug negative 2 in for x and get negative 3 over negative 2 minus 5. The first fraction comes out to negative 3 over negative 5. The second fraction comes out to negative 3 over negative 7. Both fractions have double negatives, which I'm going to change to positive. So I'm going to make this 3/5 minus 3/7. The minus sign between stays, but the double negatives in the fractions cancel. First fraction, I'm going to multiply by 7 over 7. Second fraction, I'm going to multiply by 5 over 5. And I'm going to get 21 over 35 minus 15 over 35. And that's going to be 6 over 35. And I'm going to, oh, that doesn't reduce, does it? No. No. So I think my answer is 6 over 35. Let me go to my calculator and make sure 6 over 35 matches. So if I do 6 divided by 35, I get essentially exactly that. So I feel good about that answer. Let me slow down when I do problem 14. I just felt like I was maybe racing a little bit there. The nice thing about the videos is you can watch them. You can watch them as many times as you need. Pause it and watch me do something twice if you need to. Let me do problem 14. There's not enough room here, so let me rewrite 14, which is the integral from 1 to 3 of 6e to the 2x dx. 14a is going to be easy because I'm going to use my calculator. So on my calculator for 14, I'm going to graph the function 6 and then second and ln, and then e to the 2x. I can graph that if I care to see the graph. And then second trace, go down to option 7, lower limit 1, upper limit 3, and I get 1,188, and then 0.119, I'm going to round that to 0.12. It's a big number. When I do 14b, my answer is going to probably have e's in it, and it's going to have a decimal equivalent to that. So first I need to integrate the integral from 6e to the 2x dx. I'm not going to worry about the numbers here for a second. First thing I'm going to do, when you're integrating with an e, you let u be the exponent of the e. So I'm going to let u be 2x. I'm going to rewrite this problem as 6e to the u dx. I'm going to take the derivative of this with respect to x and get du dx on the left side. The derivative of 2x is just 2. I'm trying to replace the 6, so I'm going to multiply both sides by 3. And this is going to give me 3 du dx equals 6. So I'm going to replace the 6 with the 3 du dx. I'm going to leave the e to the u dx. And since all I've done now is replace this with what it's equal to, I'm going to cancel out the dx's and write this nicely. This is going to be 3 e to the u du. And now I'm going to integrate that using the rule that says the integral of a times e to the x dx equals a e to the x. Technically plus c. I'm not going to put the plus c in because when I plug the numbers in, the c's would cancel. So I'm going to say that this, the integral of an e with a nice exponent of just a single letter without an exponent or coefficient is it's its own integral. I'm going to change the u back to 2x, and now I'm going to bring the numbers 1 and 3 back. And I'm going to plug the number 3 in for x and get 3e to the 2 times 3. And I'm going to plug the number 1 in for x and get 3e to the 2 times 1. Subtract those. This is going to give me 3e to the 6 minus 3e squared. You can certainly write that as my answer, and I think that's where I'm going to stop. I can absolutely factor out a common factor of a 3. I actually could factor out a 3e squared, but I'm going to call that my answer as long as its decimal is equal to 118.1192. So I'm trying, when I pull out my calculator and look at my exact answer, I'm trying to make sure my exact answer is equal to that. So back to my main screen, I'm going to do 3 second ln e to the 6th minus 3 second ln e squared. As long as my answer comes out to that, I feel good about my work. And it comes out perfectly. It has a few more decimals, and that's completely fine. $15 is the one problem on the test where we don't need to do any calculus. We can do the whole thing on my calculator. And what I've done is I've graphed two functions for you. I graphed a function f of x, and I said this is a graph of f of x, and it's drawn in blue, or with a dashed line. And then I graphed the function g of x, which is graphed with a solid line. And then I said, use your calculator to find the shaded area. To find the shaded area, I'm going to have to integrate. And I'm going to have to do two separate integrals. The first bit of the shaded area, I'm going to integrate between x equal to 1 and x equal to 3, because the x coordinates of where those shaded areas start and stop are 1 and 3. And I'm going to do the top function. In this case, the top function is the g function minus the bottom function. In this case, the bottom function is the blue function. That's the first area I'm going to compute. And then I'm going to compute a second area. The second area is going to be done with an integral. It's going to go from x equal to 3 to x equal to 6, because for this second region, the x coordinate of where the points cross is 3, the x coordinate of where the shading stop is 6. So I'm going to integrate between 3 and 6, all on my calculator. And in this region, the function that's the higher function is the blue function, which is the x plus 1. The function that's the lower function is the red function, which is the 7 minus x. So I'm going to do two separate integrals on my calculator. I'm going to get a number for this area and a number for this area. The first number should be smaller because the area is smaller. The second number should be bigger. So let me do these separately. First one, I'm going to enter parentheses 7 minus x parentheses minus parentheses x plus 1. And I'm just going to go straight to integrating. I'm going to go second, calc, go down to option 7. It kind of messes up the graph when you subtract, but it's okay. Lower limit 1, upper limit 3. The first region, that triangle there, has an area of 4. Done with the first region. Now I'm going to enter this function in my y1. So in my y1 now, I'm going to enter the function x plus 1 minus parentheses 7 minus x. And I'm going to integrate that, lower limit 3, upper limit 6. So second trace. Don't care what the graph looks like. Lower limit 3, upper limit 6. That area is 9. So the area that's gotten from the two shaded areas, That region has an area of 4. This region has an area of 9. When I add those two numbers together, this is going to find the shaded area. The answer to problem 15, the shaded area is 13 square units. Alright, this is going to be another hiccup in the video because I made a mistake. Evidently, I should maybe just stop now and finish the videos later, but I just feel like getting it done. So hopefully I can do a decent job here. So 16 gives me a function, f of x equals x squared minus 4, and it gives me a window. And what it asks me to do is sketch a graph of this function with an x min in my window of -1, and an x max in my window at 3. Let me use my calculator to do this. My calculator might be halfway set up to do this because I've done it already. So I'm going to go y equals x squared minus 4, and I'm going to set my window. My x min is going to be -1 for this -1. My x max is going to be 3 for this 3. I think the y's turned out to be fine. At this window at -10 to 10, when I hit graph, the graph didn't shoot off the top or bottom of the screen, so this was an okay window. So that's a reasonable picture. I'm going to need to know this x-intercept. It's going to be important, and I'm going to be asked to find it in part B. I believe it's at x equal to 2. I believe the graph looks something like, let me just do a really inaccurate graph. I think the graph does something like this. Turns out that I don't really even need to know the y coordinates of that point or that point. As long as my graph has an appropriate x-intercept, the graph will be fine. So I'm starting at this point. I just kind of estimated it, ending at that point, and going through the x-intercept. Let me make sure that this graph it's reasonable. To be reasonable, it has to look like the picture here, and it has to have the right x-intercept. These y's, if you don't have them exact, it's not that big of a deal. If I wanted to get it exact, I could just go table. The point here needs to be the point -1, -3. So if I was graphing this nicely, this would be the point -1, -3. And this would be the point 3,5. So you can definitely mark up the y-axis and get a really nice graph. 1, 2, 3, 4, 5, -1, -2, -3. You can do that just fine, but you don't have to. It's going to be more important to get the right x-intercept. Part B wants me to find any x-intercept that's in between -1 and 3. I'm going to find the x-intercepts for this graph by setting the function equal to 0. I'm going to factor, and then I'm going to set each one of the factors equal to 0. This graph has two x-intercepts, and the x-coordinates of the x-intercepts are -2 and +2. If I continued this graph, it would have an x-intercept that's outside the window of -1 to 3, and the instructions in part B say find any x-intercepts in between A and B, in this case in between -1 and 3. This x-intercept is not in that window. I'm not going to worry about it. This x-intercept has an x-coordinate at 2, and it's technically the point 2, 0. So for the answer to part B, the x-intercept that's in the interval between x equal -1 and x equal 3 is the point 2, 0. Done with part B and part A, I have a reasonable graph, and I have the x-intercept labeled. Part C wants me to find an area, and real specifically, what it's going to ask me to do is to find the area between x equal to -1 and x equal to 2, and then find the area between x equal 2 and x equal to 3 and add those together. So what I'm supposed to do is find two separate areas, and the area between the x-axis and the graph of this function is the sum of these two areas. The first area I'm going to get by integrating. between -1, which is the x-coordinate of that point, and +2, which is the x-coordinate of the x-intercept, the function x squared minus 4 dx. Because this graph is beneath the x-axis, this area is going to come out to a negative number, and I'm going to make it positive by taking its absolute value. The second region is above the x-axis. When I do that area, it's going to be a positive number, and that's going to be found by doing the area between 2 and 3, or the integral between 2 and 3, of the function x squared minus 4 dx. I'm going to integrate each one of these. To integrate this, I add 1 to the exponent, divide by the new exponent. To integrate the minus 4, you just tack on an x. So this integral, I have to evaluate from -1 to 2, the function x cubed over 3 minus 4x. This is going to come out to a negative number. I'm trying to make an area as opposed to a definite integral. They're related, but not exactly the same. I'm going to make that number positive. And then I'm going to do this computation. This integrates to x cubed over 3 minus 4x. And I need to do that between 2 and 3 as well. So I'm going to find a number for this and a number for this, and then I'm going to add them together. These I'm going to do on a separate sheet of paper because I just didn't leave myself enough room. So that first thing that I wanted to compute is x cubed over 3 minus 4x. Evaluate it from -1 to 2. Because that corresponds to this region, integration makes areas beneath the x-axis negative. I want this to be positive, so I'm going to take the absolute value of this number. And let me do this the best I can by plugging in 2 for x and doing 2 cubed over 3, and then plugging in 2 for that x, minus 4 times 2. I'm going to do that result in a parentheses, and then minus -1 cubed over 3 minus 4 times -1. Put that result in a parentheses. This whole result is going to come out negative. I'm going to make it positive by taking its absolute value. Now I'm going to use my calculator because I'm tired and I don't want to do these by hand to make another mistake. So this first parentheses is going to be parentheses 2 up arrow cubed divided by 3 minus 4 parentheses 2. And I go math, enter, enter. That's -16/3. The second area is going to be parentheses -1 up arrow cubed divided by 3 minus 4 parentheses -1. And then math, enter, enter. That's 11/3. So now I need to do -16/3 minus 11/3. And again, I'm going to do that on my calculator because I feel like I'm going to make a mistake if I do it by hand. So -16 divided by 3 minus 11 divided by 3 should come out to a negative number. It comes out to -9. And I'm going to make that positive. So the very first region that I'm worried about, that region right there, its area is 9 square units. I'm going to put that right there in my work, and now I'm going to go on to do this blue area. I won't have to worry about the absolute value signs because that portion of the graph is above the x-axis. It's going to have a positive area anyways. I'm going to do this completely on another sheet of paper because I don't have enough room. And what I'm trying to do is x cubed over 3 minus 4x, evaluate it from 2 to 3. To do this, I'm going to do 3 cubed over 3 minus 4 times 3 in a parentheses, and then 2 cubed over 3 minus 4 times 2 in a parentheses. Let me do both of these on my calculator because, again, I'm just making too many mistakes right now. So 3 up arrow cubed divided by 3 minus 4 parentheses 3. This first one comes out to -3. I'm going to bring this minus sign down. And for the second one, I'm going to go parentheses 2 up arrow cubed divided by 3 minus 4 parentheses 2. and I get math, enter, enter, a negative 16 over 3. So this comes out to be negative 3 minus negative 16 over 3, which is the same as negative 3 plus 16 over 3. Let me do that on my calculator. Negative 3 plus 16 divided by 3, math, enter, enter, and that comes out to 7 over 3. So the blue region has an area of 7 over 3. So green region has an area of 9, blue region has an area of 7 over 3. The answer to part C is going to be what I get when I add those two areas together. So 9 plus 7 divided by 3, math, enter, enter. The answer to question part C, the area, combined area, is 34 over 3 square units. Yuck, 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 yuck. All right. But there's 3 more problems on the review. Let's just get them done. So 17 gives me 2 functions, an f function that I'm going to draw in blue, a g function that I'm going to draw in red, and I'm going to draw those over the windows 1 through 3. Let me sketch a graph real quickly. On my x-axis, I'm going to put the numbers 1 and 3, and I'm going to draw first x squared minus x. So I'm going to go y equals clear x squared minus x. For my window, I'm going to go x min 1, x max 3, being lazy and not worrying about the y's. Let's graph this in blue. And let me try to find the y values of these points by going second table. Next to 1, it's 0. So the first point I'm going to graph is the point 1, 0. And next to 3, it's 6. So this first graph that my calculator gave me looks something like that. I probably made the 6 too high, but it's close enough to that. It's a little leg of a parabola. Now, in red, I'm going to graph in y2, g of x equal to 7. Super easy for me to do. I'm just going to go to y2. I'm going to type 7. And I'm going to hit the graph button. And I knew what this graph was going to look like because it didn't have an x. It was going to be a straight horizontal line. That graph looks something like this. Starts at x equal to 1, goes off to x equal to 3. That's the g of x equal to 7. I'm supposed to find the area that's kind of boxed in by these. So I'm supposed to find this area between x equal to 1 and x equal to 3, the area between these two curves. Not so hard to do this. To find areas between curves, you integrate. The area that's marked here is going to go between x equal to 1 and x equal to 3. It's going to be the top function, which is g of x, which is 7, minus the bottom function, which is f of x, which is x squared minus x. When I do that subtraction, I need to subtract in a parentheses. So the area that's shaded there is given by that region. Let me clean this up a little bit and get another sheet of paper because I just didn't give myself enough room. I'm going to clean this up. This is going to be the integral of 1 to 3 of 7 minus x squared plus x dx. So I just cleared the parentheses by flipping that sign. And now I'm going to integrate. And when I integrate, the first term's a constant. Its integral is going to be 7x. The second term, I add 1 to the exponent, divide by the new exponent. The third term, I add 1 to the exponent, divide by the new exponent, and evaluate that between 1 and 3. So this area is going to be found by doing that computation. For that computation, I need to take all these x's and plug 3 in. So I need to go 7 times 3 minus 3 cubed over 3 plus 3 squared over 2. And then I need to plug 1 in and go 7 times 1 minus 1 cubed over 3 plus 1 squared over 2. I'll do each one of those computations and subtract the results. Completely calculator worthy, so let me go to the main screen of my calculator and do this side first. So 7 parentheses 3 minus 3 cubed divided by 3 plus 3 squared divided by 2. Math, enter, enter. This side comes out to 33 over 2. Now I'm going to do that side. To do that side, I just go 7 parentheses 1 minus parentheses 1 up arrow cubed divided by 3 plus parentheses 1 squared over 2. Math, enter, enter, and I get 43 over 6. Almost have my shaded area. I just need to subtract those two. My shaded area is going to be 33 divided by 2 minus 43 divided by 6. Math, enter, enter, and I believe the answer is 28 over 3. If I wanted to, super easy to check. I could just enter this function in my y1. So I can go y equals, enter 7 minus parentheses x squared minus x. Don't care so much what the graph looks like, but my window better be far enough, which it is. Then I go second calc, integrate, lower limit 1, upper limit 3. I get 9.333, and that's what I got on my calculator before I changed it into a fraction. So this is a perfect answer for problem 17. '18 is a similar question. What I'm going to do is find the area that's indicated, and on my x-axis I'm going to mark two numbers. I'm going to mark the number 3 and the number 5, and I'm going to graph the two functions that are given. I'm going to graph the function x squared in blue real quickly here. So I'm going to go y equals x squared, window x min 3, x max 5, graph it, and I can't see the top of the graph because if you plug 3 in for x, 3 squared is 9. If I plug 5 in for x, 5 squared is 25. My y min and y max might need to be tweaked. My y max needs to at least go to 25 because 5 squared is 25. When we did this earlier, I went to 30, so let me go to 30. And in terms of points, if you plug 3 in for x, 3 squared is 9. 3 squared is 9. If I plug 5 in for x, I get 25. This graph right here, which I'm going to do in blue, starts at the point 39, ends at the point 525. It looks something like this. Again, my window's a little bit tweaked from my calculator, but that's okay. Now in red, I'm going to graph the function g of x equals to x. In the y2, I'm just going to enter the function plain ordinary x, and I'm going to hit graph. It's going to graph that function. The first point it's going to have is going to be the point 33, because if you change the x to 3, you get 3. And if you change that x to 5, you get 5. So the second function goes through the point 33, because if you plug 3 in for x, there you get g of 3 is 3, and it goes to the point 55. I'm asked to find this area right here. That's going to be an area between x equal to 3 and x equal to 5. And the area I'm supposed to find is the area between the two functions. Super easy to find because you find areas between functions by integrating, in this case between 3 and 5, because those are the values of x that are given. And always I do the function on top first minus the function on the bottom second. The function on top is x squared. The function on bottom is x. I'm going to integrate those and figure out what the area is. Super easy to integrate that. That integrates to x cubed over 3. This integrates to x squared over 2. And I need to evaluate those from 3 to 5, which I'll do on another sheet of paper when I write too big. So I'm going to plug in 5 for x and do 5 cubed over 3 minus 5 squared over 2. And I'm going to plug in 3 for x and do 3 cubed over 3 minus 3 squared over 2. I'm going to subtract those results. So the first one back on my main screen is going to be parentheses 5 up arrow cubed divided by 3 minus 5 squared over 2, math, enter, enter. The first one comes out to 175 over 6, and then minus. Second one I do 3 up arrow 3 divided by 3 minus 3 squared over 2, which is 9 halves. So now I'm going to do 175 over 6, which is the first computation, minus 9 halves, which is the second computation, and get 74 over 3, which was 24.6 repeating, I think. The answer to 18, the area is going to be 24.6. So my answer, the answer is going to be 74 over 3. I'm going to check this on my calculator. My calculator can give me this 24.6 repeating. To check this on my calculator, I go y equals, I enter the blue function, x squared, minus the red function, x, and then graph it, do second calc, integral, lower limit 3, upper limit 5. And when I do this on my calculator, I get 24.6 repeating, which is what I thought it should be. There's technically one more problem on the review. I never put that problem on the test, and I kind of feel like it's kind of getting to be a little overwhelming right now. So let's just go ahead and vote to skip this. I won't put this on the test. Never have. Don't ever plan on doing it. And we'll just stop with these 18 problems. I think that's more than enough to get perfected before we get to the test.